Welcome in the third section of our course. In the first section, we'll be understanding basics of deep learning. First topic that we'll be focusing on is understanding basics of deep learning. So we will need to understand basic constructs that are needed to create more sophisticated things and algorithms in deep learning fashion. In the second video, we'll be looking at the ND4J for NumPy-like arrays and operations. Once we will know that library well, we will be looking at the data vector. This is another abstraction construct from that library that is a main point for every deep learning algorithm. Also, as you remember, in machine learning world, vector is a most important construct. We are creating vector of features with those features, and also in deep learning, we are creating vector that is an input to our algorithm. In the last video, in this section, we'll be looking at the deep learning 4J for building neural net architectures. We'll be looking at the vector statistics, and also it can be useful for understanding our input data that is used to train our deep learning model. And this is a first video of this section in which we'll be doing understanding basics of deep learning. So we'll start from adding ND4J library. We'll be doing and creating instance of ND array, and also we'll create a matrix using the same library construct. So here is our build.sbt file. To have available ND4J, we will need to add a couple of dependencies. Most important, of course, are org.nd4j. We need to have an API that is a generic API for creating those types. It is important for us. Next, we will need a native package. Native package has a lot of dependencies specific to your platform. So if you are running that program on the Linux, it will have native Linux things, Mac OS X, and so on and so on. Later, we need native platform. This is a bridge between native and API. Once we have that dependencies, we will be able to create and leverage that library. So let's look at the create matrix. So we'll be using ND4J for creating basic matrix. First, you are specifying number of rows equal to 3 and number of columns equal to 4. It means that our matrix will have 3 rows, 4 columns. We are using ND4J zeros static method for initializing everything inside of our matrix, our IND array, with zeros. So we will have 3 times 4 zeros. Once we construct that, we can print basic information about our matrix. First information is, of course, number of rows, then number of columns. We will assert that this is equal indeed to those parameters. Next, we will examine number of dimensions. This is also important property that tells us something about input data. We can get a shape of our matrix, you will see what is it, and also length. So once we will have that, we can print the content of whole array. But up to this point, it will be quite boring because all elements are equal to 0. We want to do something more. It will be in the next step, but let's focus on the next steps right now. We can get a size of dimension number 0 and dimension 1. You will see what is it. Also, we can transform our array into vector, into scalar, into matrix, and into square matrix. So let's start this test and see what our output will be look like. We can see that we have number of rows equal to 3 and number of columns equal to 4. So this is proper. Number of dimensions is equal to 2 because this is just a simple matrix of rows and columns. In the real deep learning approach, sometimes we'll have more dimensions. It is hard to imagine for a person and for a human to have more dimensions, but we have such possibility using that library. Our shape is 3 to 4. Length is equal to 12, so it is 3 times 4. Contents of our array is filled with zeros, so all zeros here. We can see that number of rows is equal to size of 0, dimension 0, and size of 1, the second dimension, is equal to number of columns. we can see that this is not a vector because it returns false. It is not a scalar because it returns false. It is a matrix, but not square matrix. Square matrix will be if you will have 3 rows and 3 columns. Let's examine the second test in which we'll be populating that array. So this time we are creating 4 rows and 10 columns. We are filling everything with zeros as well, but at the beginning we are getting double at index 0 and column 1. We'll see that this value is equal to 0. But we can add an element 1.0 to every entry. This is counterintuitive because in the normal array or list, if you will call add method, it will add the element only once, at the beginning, at the head, at the tail, or whatever you specified, but not to all. But int array is a construct optimized for deep learning. And for deep learning, this is really often the case that we need to add a specific value to every entry in the array. So we'll add 1 to every entry. Also, we have multiplication of every entry as well. So this is a batch operation and it could be executed in parallel. So the more cores you will have, the faster it will be. And in the real world, that array will be really big because we will have a lot of data in it. So let's start this test and examine it. We can set value at 0.1 was 0, 0. Then after adding 1 to each entry, we can see that all values are equal to 1. And then after multiplying every entry, everything is equal to 2.0 because this is a float number.